Hello and welcome everybody to this live stream. A good morning, good afternoon, good evening. Where are you in the globe? One of these will be relevant for you. It's very nice for us to know where you are, who you are, and where you are from. So yeah, we encourage you to use the chat for what it's supposed to be for. So please communicate and share with us where you're from and who you are. And yeah, we're looking forward to start this off. So a very warm welcome from myself and Stanley de Vries. We are now live on YouTube, on LinkedIn, and on Facebook. And we are here to inform you and tell you about the importance of pressure-independent temperature control. We are very much looking forward to the event and hope you'll find it interesting and relevant. So yeah, keep the questions and yeah, make sure that that you get to know what you want to know about this exciting topic. So if you're out there and you think that there's maybe colleagues or other interested people close to you that should also get to know about this, still feel free to share the link that you are using for the live stream and share it with your with other people to make our audience today as broad as possible. First of all, my name is Raymond. I'm working in Danfoss for 25 years now. The last 15 years of that in a position in marketing support. And I'm very happy to announce that my colleague Stanley de Vries, he will be the person explaining you about the questions and giving you the answers to them. So Stanley, can you please very shortly introduce yourself?
Yeah, hi. Good day. I'm Stanley de Vries, and I've been working for Danfoss for 20 plus years. And also I've been active basically all over the globe, from Korea to Brazil, from the Middle East to the US. And in these 20 years, I've spent a lot of time, actually also trying to share the knowledge that Danfoss has as a Danish company that is very much into energy saving and very much into good solutions for HVAC, and to share this knowledge with all the customers that we have. So I hope also to see some familiar guys' names pop up here. And yeah, so today we'll be talking about the pressure independent temperature control. And let's by the way, good day to Denmark and India, I see already. So that's good to see.
Exactly. Yeah. I encourage everybody to share with us who you are and where you're from. Let's keep it coming in. We can see your messages and yeah, along the way, this live stream, please put in your questions. We definitely set this up to communicate with you. This event is about you, not about us. So we would definitely like to help you and learn more about PICV and the technology behind. So Stanley is here to explain you everything that you need to know. But we want this live stream to be relevant and informative for all of you out there, and we want this definitely also to be a dialogue. So please come with your questions into the chat, and we'll do our best to answer them along the way. And those questions that we might not be able to answer, we'll do our utmost to inform you about these after the live stream as well. The live stream will be recorded, so there's also a possibility for you to look things back in case you want that. So yeah. As a start, this part was the welcoming part. I would now like to hand over to Stanley. He has prepared a very short presentation to just kickstart the discussion and the interactivity here. So Stan, please go ahead. The floor is yours.
Yeah. So thanks, Raymond. And I would like to repeat that we very much ask you to ask the questions. The chat is there. So please shoot in the questions while I'm talking. And if there's something that's relevant to what I'm talking at that point of time, Raymond will try to interrupt me. And yeah, because ideally we will have a conversation here, right? It's not a one-way seminar that I'm giving about controls or whatever. It's if there's something you want to know, then for sure let us know, and we'll try to get the question somewhere in the flow. Ideally, I will not come to the end of the presentation. This is what I was told. So please help us realize that. All right. So as Danfoss, I think, let's say 15 years ago, probably, yeah, we started launching pressure independent control valve. And that is, it has basically evolved into a product that is widely accepted and also has been used widely. And right today, actually, I want to kind of talk to you about, why we still think that this is one of the most crucial aspects of our offering, is the pressure independent part. So first, if we start off basically on the basics, let's say, then we can say, okay, what does it mean to have a precise temperature control in the building? Because we are all in HVAC, and that is our end goal, right? Is to have the good indoor air quality. And I think basically everybody, even if you're not in HVAC, can understand what it means to have a good temperature control. It basically means if you set the temperature to 22, that in the room it will be 22. So that's what everybody understands. However, I think that the people that are actually working in HVAC, they really understand that there's a lot of things that need to happen actually before this precision actually happens, so that you ask for 22, you get 22. And this is really not simple, but it's also a very crucial part, because first of all, obviously it's a comfort issue, right? We want people in buildings to be cool or warm, and this is why the HVAC system exists, why we do the heating, the ventilation, or the air conditioning. So so that is the, let's say, our raison d'etre actually for being in this business. But we can also say that the good control is also very important for the energy efficiency. So if you have the system good under control and you have everything controlled properly, that means also you will have a very efficient system, because you can say that the control basically ties all the components of the system together in a good way. Wow, Trinidad and Tobago, that's interesting. Never been there. I want to visit one time. So the energy efficiency is also for a good part actually caused by a good control in the system. And last, and this one will probably get a bit more prominence in the near future, the humidity control is also quite important, which is also very much tied into the precision, because we all know we're still kind of in the middle actually of a pandemic, or let's say at least in the tail end for some of us, but for some of us very much in the middle. I saw somebody from India. It's still quite serious there, for example. And we all know that the spread of this pathogens, so let's say viruses and COVID viruses and those things, are very much also tied to humidity control. So you already see discussions coming up, and let's say about, okay, so how should we control this? And we know that if you maintain a certain level of humidity, then you actually have a better control of the pathogen spread in the building. So basically, above 70 is really not good. So people from Malaysia or Singapore, they might want to control that. So
Stanley, we have a first question coming into the chat from Alexander, and Alexander is questioning, what does PICV actually mean? Can you explain this in a proper way?
Yeah, I mean, PICV is one of the names that is generally accepted in the market. And the PICV is an abbreviation that stands for Pressure Independent Control Valve. So it is a control valve. I think most people in this room will know what is a control valve. It's something that has an actuator on top that is used as a control device to control temperatures. And pressure independence means that it doesn't have any, it's not influenced by pressure fluctuations in the system, which I will also touch on later a bit. So it's pressure independent control valve. This is what the abbreviation means. There are also certain other products that have similar names. So the name PIBCV is used, pressure independent balancing and control valve. It's basically the same thing. Then we have also PICCV, pressure independent characterized control valve, which is more or less the same. So that's also one of the things where our business in general is pretty good at finding different names for the exact same thing. I think if you give me 10 minutes, I can find probably 5 or 6 different names for manual balancing valves, just to give you an example. And but yeah, it's our main topic today. It's the pressure independent control valve.
Yeah, that's clear, Stanley. Good reply on that. And it is actually more than just this abbreviation. There's a real meaning to it, and really a category of a product. So like Alexander, please, everybody, keep your questions coming in, and go ahead, Stanley. Sorry for the interruption.
No, it's okay. So if we can go back to the presentation, then we can... are we back to the presentation? Yes, we are.
Yes, we are. Yes.
All right. Again, we're still talking a bit about basics here, and I think many of you are basically seeing this not for the first time, because I think everybody of us has had an education in controls and training like that. But suppose we're talking about, I don't know, an air handling unit or a Venco unit application, then this is what the control loop does. And it's really a loop, right? So it is a continuously repeating process. And so basically we get the room temperature or the control temperature in here. We compare that to the set temperature. So what is the desired temperature? Then we calculate what is the deviation. Then our control device, which is in this case a control valve, could be cooling or heating. And then the process, which is basically the temperature, the air that we are cooling or heating, is corrected by either opening and controlling the control valve. However, this is not the whole process, because the eagle-eyed amongst you have seen that a bit is missing. And that bit is actually the disturbances. Because if the process was just like I just showed, it would be quite easy to do, because then everything is fixed, right? And then you don't even need to control anything. It's just, you put energy in, you know how much energy goes out, and then that's it. But in our HVAC situation, we do have a lot of disturbances, and they could be basically be, let's say, room load changes. And those room load changes would be either more people moving in or out of the room, or an outside temperature that changes. So, or sunlight getting into the room. And those are external factors, and they also tend to be fairly slow. So, I mean, if the outdoor temperature changes, I think it will probably take hours before you actually notice that inside, because there's a wall in between, or there's a window. Sunlight is a bit faster, because that goes through the windows, but also the room will not warm up that quickly if you add additional people in the room. unless you overdo it. I mean, many people have sit in hot conference rooms here, I'm sure. So, and those are external factors. What we also have are, let's say, factors that are caused by the process itself, so the installation, and that is that is how does the actual installation function, and many of those influences or factors are actually pressure fluctuations, because nowadays most of us use two-way control valves in the system, and we all know that if control valves open or close somewhere, then that has an effect in the water distribution. I would also like to add at this point that I'm skating over a huge amount of theory and practice behind this, but because there's basically about every sentence we can do another 1 hour presentation. But again, let's try to make this a conversation. So please let me know what you want to know, and then I'll try to go deeper into this.
I think we have a good question from Farhan related to this, Stanley. He's questioning, you talk about pressure fluctuations in the system, but what is actually the cause of these? Can you explain that?
Yeah. So as I said, nowadays we mostly use two-way control valves, right? So that means that there is a valve, like we can see here in the picture, that basically allows a certain amount of flow through the through the valve. So it can be more or it can be less flow. So now, if you close one of these valves and you allow less flow because you have a less need for output, so let's say you're heating the room and the room is almost on temperature and you want to close the radiator or whatever it is you're using, then that means that actually the flow through the installation shifts. And you can kind of compare this with a garden hose. So if you have a number of holes in a garden hose where a certain amount of water is coming out, then you will see that there's a certain flow there, and it might be a nice fountain or something. But if you actually close one of the holes in the hose, then you will see that the water through the rest of the holes will actually increase. And yeah. I mean, I also seen this process actually in some kids' playground toys where they have, you know, fountains that are popping up all over the place. If you close, let's say, one of the fountains, and if you basically restrict the flow there, then the flow will redistribute and come out somewhere else. And this is basically what causes those pressure fluctuations, because pressure and flow in a system are very, very closely connected. So there is no way that you can change the pressure without actually changing the flow.
Yeah.
And
but this also relates a lot to the building, how it looks and how it is designed, Stanley. So you have, for example, northern part of the building, and another part faces the south, where the sun inlights is much stronger. So this is also about handling these different kind of situations, as I understand you.
Yeah. So if you have, for example, let's say, as you said, you have a south facade and a north facade, then the south facade will have sunlight and will be much warmer, and there's no need for heating anymore, or there's a lot of need for cooling, but let's stay with heating for now. So there's no need for heating anymore. So that means basically all the valves on that side of the building will close, and it will push the flow through to the other side of the building. Now, obviously, nowadays we use also pressure controlled pumps. You should all do that as well, because it's basically one of the most important energy saving functions you can do in the system. But the speed control pump does not fully solve this issue. So there will always be an increase in pressure and definitely a fluctuation in the pressure. And this is also, as I was talking about slow influences, this is also can be fairly quick, because if valves open and close, that can be a fairly quick process, and that means that your valve will actually be also influenced by that, because if you increase the pressure on the valve, the flow through the valve will be increasing, which is really, as I was mentioning before, this is about the connection between flow and differential pressure. So that was a good question. So any more, feel free to ask them.
Yeah, thank you, Farhan, for your question, and for the rest of you out there, keep the questions coming in. We're not at the end of this session so far, so keep the questions coming in so we can use them. But maybe you can continue on the presentation part, Stanley.
Yes. So as I was saying, I was talking about disturbances, right? So we have external disturbances, which have mostly to do with load in the room or in the building, and how it's distributed across the building, and then we have also the internal pressure fluctuations. That part is actually pretty crucial if you want to understand proper control. So then now we come to the PICV, which, as I mentioned before, is a pressure independent control valve, and it is basically a 2-in-1 valve. So we have a control valve, and as I mentioned before, everybody also knows what a control valve does. It controls the temperature in the room, but we also have this combined with a pressure controller internally. So the motorized control valve is basically taking care of the room load changes. So if you remember the control loop, it is very much talking about the difference between the actual measured temperature in the room and the set temperature. What the pressure controller does, actually, the pressure controller is only focusing on these pressure fluctuations that you will have in this in the system. So and right away you can kind of understand that this is making the life of the control valve easier, because certain sources of disturbance are actually just completely locked out. So and also we have to understand that the pressure fluctuation, which means basically a flow change through the valve, will also have an effect, because the flow that we use for heating or cooling is directly proportional on the amount of cooling or heating we do in the room. So if we have a Venco unit and we have, I don't know, 200 liters per hour flowing through the Venco unit, if we do that, if we double that flow, we will actually also see a large increase in the cooling capacity. I will not say double, because it's not exactly double, but that's again a completely different technical discussion. But with the pressure controller, you know that when I open the valve 50%, my flow is also always 50%, no matter what happens in the rest of the system. And this is the crucial version.
Yeah. And we have a question coming in related to this, Stanley, from David Martin. Is this a new version of the ABGM, and it's available in all countries?
Yeah, I would say this is more a marketing question for you, but yeah. But
that's also
yeah. So, but yes, this is a new version that we've introduced. It's the ABGM 4.0. I know that David seems to be at least a Danfoss buyer because he knows the proper name of our PICV. And this is widely available, I would say, in most of the world. The exception, at least I know, is the US, where we are having a different range at the moment that has different threads on the valve, because this is a European and ISO thread, as we could say, and in the US they like NC thread or MPT. And as far as I know, it's also not yet available in Russia. But yeah. So this is the new version that was launched, I think, last year, and it is widely available in most of the countries.
Okay, great. And then we have another question from Farhan, and it's a bit long, but let me try to get it to you, Stanley. This PICV is capable to use with chilled water systems where pipe material is black steel. As far as we know, there is definitely have excessive particles from internal pipe wall surface. This most probably will get effect to the PICV functionality. I think what is meant here is about the scaling conditions that might appear in these type of systems. Can you say something about this, Stanley?
Yeah, I mean, obviously, let's say the black steel or the mild steel, I don't know actually what's the proper term here, but those valves are commonly used with steel piping. While I mean, I would say if you have excessive particles, then basically there is also something that you need to take care of in the installation, because let's say, because it most of the time actually means that there's an introduction of oxygen in the system, because the particles do form, but it's mostly in the beginning when there's kind of fresh water in the system and where you have oxidation. So there's basically, if we talk about the particle forming, we have two different ways. One is if there is, let's say, oxygen introduced in the system, and one of the reasons this could happen, and we have seen this, and I personally also have seen this in certain installations where they use plastic piping, and not all plastic piping is oxygen tight. If you have, let's say, the wrong kind of piping, then you will have a lot of particles forming, because there will be a continuous introduction of oxygen into the system. Another one would be if you have, let's say, galvanic corrosion, which means that certain steels that are have a different potence basically are connected together, and they also make sure that there is a kind of electric current flowing in the system. Generally speaking, there should not be huge amounts of particles forming. However, if your question is possibly also somehow related to the clogging of the valve, which is also quite a common question, then I would say this valve does not clog easily, because that's also a common concern that I heard from a lot of customers in the last 20 years. So how easily does this valve plug up with dirt and stuff like that? I mean, I would never say that that it would not plug up, because I mean, depending on whatever you have in your system, it can always do that. But it is certainly not more sensitive to that than for example, a normal control valve. Because the normal control valve also has the small openings and things like that. In this case, we can actually say that to a certain extent, the valve is also self-correcting, because the differential pressure controller will try to keep the same flow. So if there's a certain clogging in the valve, it will open up and it will allow more pressure, which will either flush the system, or it will make sure that the flow is maintained.
Yeah. Okay, great. And we also see another question. I cannot see who actually asked for it, but I see that there is a question about the availability of QM. I assume that this question means if the product ABQM, if that is available in all countries. And yeah, to the extent I can answer on that, and correct me if I'm wrong, Stanley, but yes, ABQM is a Danfoss product category that's basically available globally. And what we discussed a little bit before is a dedicated new version, ABQM 4.0, that is available in smaller DN dimensions in most parts of the globe. But in that case, there are a few exceptions that it's not available in every country. So I hope that that answers the question that we have received on this. Yeah, so people, yeah, keep the questions coming in. We're looking forward to answering more of the things that you would like to know about these type of control valves. Yeah, please continue, Stanley.
All right, so as I was saying, the differential pressure controller takes care of the fluctuations. So if you look at the valve design, we have an actuator that fits on the top. Then here we have the control valve, and on the bottom we have the pressure controller. So this this kind of gives you let's say the overview of how the valve works, and it is important because it will give you the very precise control in the valve, and the pressure controller will make sure that you also have a high authority on the valve, which is basically saying that it is very precise in control, but also again a very big subject on its own, which we might cover in later live streams, for example. So, by the way, these are only small valves. I think that, I know that the valve is available up to 10-inch, 250 millimeters. So I think that covers basically all applications. I mean, also on the clogging part that we were just discussing, if we look at actuators that fit on top, we nowadays also have what we so-called digital actuators. So, and those digital actuators can actually sense if the valve can properly close. So if you have a system where you have where you expect dirt and that the valves cannot properly close, then this actuator will actually tell you, hey, something is wrong here. But I must say, I mean, Raymond mentioned that we sell all over the world. So, from India to Brazil, to Russia, to China, to Sweden. I would say that the amount of problems we had with clogging valves is very, very limited. So,
okay. Stanley, this is maybe also a good step to something that I can show from this side. You have mentioned these ABQM being available in a bigger size range up to 10-inch DN 250. And you also just touched upon the possibility to have different actuators on them, for example, digital actuators. And maybe it's relevant for the audience to know that there is a great interactive infographic available that you can free download from our website. It's available in several different languages. But just to very shortly show this, I have it on the screen now. And basically from the starting page, you can select which kind of approach you would need for small combinations with small DN sizes up to medium, large, and extra large. And if I, for example, select the large combinations referring to D125 or 150, if I click that, you'll get to see the most important information about the pressure independent control valve itself and why would you choose that. And then here in the bottom, you can also click to find the matching actuators that actually fit on top of this specific ABQM valve. So in this case, there is a few options available, either digital or modulating actuators with a very simple to use selection information. Just with the first-hand information, what do you need to know to make a kind of pre-selection? And then if you're interested to find out more details about a certain preferred actuator, let's assume that the Novocon L, the digital actuator, would maybe fit to a project. Then you can open the data sheet from that specific actuator, and in the technical data sheet, again available in several different languages for most of these products at least, you'll find all the technical details that you need to know. So that was just something to show, and if our viewers are interested in this document, my colleagues will put up a link to it in the chat, and yeah, make sure to download it. So then we can turn back to you, Stanley.
Yeah, thanks, Raymond. That was great. I think also that this is also important to mention here that this is also one of the big advantages of having pressure independent control valves, that the amount of calculation that goes into actually selecting a valve is drastically reduced. And with that, basically, it's just, you select the flow, and the flow is calculated by the designer in the system. And if that flow fits into the ABQM range, that is the right valve. And that is not how we are used to doing things a long time ago, where we had to basically calculate KV values and authority of valves to basically make sure that we could do the control in the proper way. To get back to the presentation, as I was saying, the valve has a pressure controller, and that gives you a very predictable and precise control. And obviously, we can go very deep into how this actually works, but sometimes it's just better to look at results. And if you look at how it behaves, then if we see this graph, then here on the bottom we see 0 to 10 volt control signal, and here we see the actual flow. And you see that the different colors of lines basically represent different settings of the valve and also different pressures, so different available pressures. If you if you see how it responds, basically, you see that it always responds in the exact same way, at the exact same predictable ratio. So it's 0 to 100% at all pressures and all settings, and it will always give you a straight line with regards to the control. And this is important because you want to be predictable in your control, because that will make the control of your system that much easier. Because if you remember the control loop, then basically you have a response that is created by the control device. If this control device is very unpredictable, so the one time it will give you a very large response, and the other time it will give you a very small response, then it is very difficult to control. I mean, let's say if you're driving a car and you're using the gas pedal, and at one time, pressing it a centimeter will give you, almost nothing and the other time 1 centimeter will go from 0 to full power, then this will not be the easiest way to control your car. And I'm guessing also you will get some speeding tickets. So predictability is really important, and it also basically gives you the actual response that you want.
Okay. We have one question coming in that's a little bit different topic. It turns back to the product of ABQM. And Eddie is questioning to us why the ABQM for DN25 in the high flow version and DN32 high flow version, why these are not available with test blocks, and why the ABQM with the internal thread is available up to DN20 and not up to DN50. Can you explain something about this, Stanley? Is there a logic answer to this? Are we maybe in a process of developing more versions with, for example, the internal thread? Do you have anything to share on this with our audience?
Yeah, I mean, let's say to stay with the test plugs, the HF versions are also available with test plugs. The exception might be if you actually want to buy them in the US, because as I said, we have a different range there, which at this point does not include test plugs.
Okay.
But yeah, if you and then the internal thread, that is coming, because the let's say the development of such a range of valves is basically a continuous process, more or less. When we finished updating the whole range, we start again, you know, redesigning everything. And right now we introduced, the question before was about the new version. So this version was introduced, but it's also not complete yet. So the 25 and the 32 versions of these will come basically, let's say right now towards the end of the year. And they will also include internal thread. And then there will also be all versions, external, internal, with test plugs. And then also we will change the range in the US. So basically, I guess that all the things you want will be available Q1 next year.
Okay, that's something that I think Eddie will appreciate hearing from us. So thank you for that. Good question, Eddie. And again, to the other people viewing, let's keep the questions coming. We're looking for your good questions to answer them and help you understand the PICV and the technology even better. So keep them coming, please. Feel free to continue, Stanley.
All right. So as I was saying, that the predictability of the ABQM is basically very important, so that you always know what will happen. I mean, again, in the car, you also want predictable response, right? And a car is basically a very, I mean, people are a very advanced form of control, because we have many sensors that we have eyes, we have ears, we have, you know, feeling and sense and touch, and even smell, although I don't know that you use smell with driving cars, but I hope not, at least. And we have to realize that in an installation, you basically have only temperature sensors that you can trust on, and can be quite a lot of delay for temperature sensors to feel disturbances, right? And as I was also saying, sometimes it's better to just look at results instead of looking at all the theory that goes behind. This is coming from a test that we did on a actual live situation, where we basically compared 3 different solutions. So we have the original solution was actually a 3-way valve, which is let's say for certain applications still used, but is more or less it's a solution that is outdated in many cases now. But it's still in heating, for example, used for certain reasons, and that was actually not too bad. It's 0.8 degrees fluctuation. Then we basically did not change anything about the application itself, but we used then in parallel an ABGM, so a pressure independent control valve, and then immediately you see that the stability of the control goes is improved quite a lot. And basically this is as good as you could want it. I mean, as I said, I mean, it's very easy to say, okay, I want 22, so it must be 22, but control simply is not that easy. The bottom part is actually one of those newfangled electronic pressure independent valves, which are using a flow sensor to control for pressure. And here we see that it does work under certain conditions, but not under all conditions. And this is because you can't really fix physics with electronics. Because as I was saying, you need to have a predictable response to a predictable input. So in that case, if you look here, you see that there's 3 different stages for the EPIV. Completely to the left, it was basically functioning under a fairly open conditions, and in the middle part it was more closed, and into the right part it was operating under fairly low flow conditions. And here you see the limitations of basically not using a pressure controller in this loop, because an EPIV doesn't use a pressure controller. And if you do not use a pressure controller, you will have fluctuations at some point in the system, because your response is not as predictable as if you have a pressure control.
Aha, good to know, Stanley. We have a question popping in from JC. Would PICV bring any benefits in district cooling applications?
Well, that's actually a very good question. And also I've been to Dubai quite a lot. And I think that people that know Dubai a bit would also know that there's basically a huge amount of district cooling around. Basically, if you are anywhere near a district cooling connection, you cannot even use your own chillers on the roof. And in Dubai, PICV is the standard for all buildings, basically. And the reason for that is that, yes, it does bring a lot of benefits, and specifically for the people that operate the building. Because as I was also in the beginning saying, the precise control actually has a lot of connections with how efficient your building functions. And if you do not have overflows, and remember, the pressure controller was actually making sure that you do not have overflows in the valve, then also your delta T is well maintained. So the delta T is the difference in temperature between what goes into the building and what comes out of the building, if we're talking about district cooling. Because just also for anybody that doesn't know what district cooling is, perhaps, there will be a central cooling station that will provide a large amount of buildings. And as I said, I mean, that can be very big systems. So Dubai, for example, has huge systems. But also what you see in the US, for example, on campuses, you have smaller systems that will just cover the university or the university and some residential area around. So and as I was saying, the delta T in this building is properly maintained if you have proper control, which means PICV. And why is that important? Generally speaking, district cooling companies really want you to use their water efficiently, because the more water they pump, the more costly it is for them. And pumping cost can be quite substantial in general and HVAC systems. Another point is, the bigger the delta T on their system, the more efficient their chillers work. So if you have a district cooling system, if you run a district cooling system, then you would like the building to use the cooling to the optimum amount. So that means that you have to have a good delta T in the building, because if you have a good delta T, that means you take out as much energy out of the water as you can, because the temperature is energy, right? So if you take out if you increase the temperature of the water a lot, you will take out a lot of energy from this, and that means that the whole system becomes more efficient. So if it becomes more efficient, then the cost for the district cooling utility goes down, which they will obviously not tell you. However, what they will tell you is that if you are not using the delta T properly, so if you have a too low delta T, is that you are causing them extra cost, and they will actually charge you for it. So what you see in many cases, and that, by the way, the same story goes for district heating. If you do not ensure proper delta T in your building, you will be charged extra for it. So they will give you basically a penalty, and that is one of the big benefits that PICV brings for district cooling or district energy systems in general, is that it will ensure that your delta T is proper and that you do not get penalties from the district cooling utility. And as I mentioned before, we also have quite big PICVs. They are also used. They're also used for ETS rooms, so energy transfer rooms in buildings, for the district cooling company to actually distribute the water properly. So for them, the same logic applies. But specifically, if you are connected to a district cooling, then for sure you need to have proper control.
Okay. And then we have also a question coming in from, if I can pronounce that correctly, Kitty Kun. I'm not sure if I pronounced that correctly. I hope you forgive me if I'm not. But the question is about thermal actuators used on the PICVs, and that they use more time to close and open, so maybe not the best choice. But gear actuator would in that case be more relevant to use. But then the question is regarding the price level of it. Why is the price for the gear actuator higher than for the thermal actuator? I guess that has a lot to do with the construction and the engineering of the product and the materials that are used inside of it. But maybe you can give a bit of an inside view on this, Stanley.
Yeah, so I would say the question is a bit it is double. I mean, it mentions that thermal wax are unpopular. That is true for quite a large number of countries, but here also local exceptions apply. So there are certain countries that do accept thermal actuators, and the reason is kind of mentioned in the question, because they're cheap. So would we recommend it? I mean, let's say the argument that it is slow is not really doing it for me, I would say, because as I mentioned, the ABGM is taking the fast disturbances out of the system. So that means that the actuator does not need to move that fast. And generally speaking, I mean, the maximum opening and closing time of a wax actuator is, but remember, it's maximum, it's like 2 minutes or so. However, if the actuator is under temperature, so if it is already warmed up, it's much faster. So, I mean, I know that this argument has been tossed around a lot. I'm not sure I fully agree with the speed. I do know that the gear actuators generally are much more reliable, and also they last longer. So and also the precision is much better. And then if we talk about the actual price difference, yeah, a wax actuator is basically or a thermal actuator is basically a wax element with a heating coil around it. So what happens is you heat up the wax element, and because you heat it up, it expands, and then and basically it opens or closes the valve depending on which actuator you have. But so that is actually very simple systems, and there are certain ones that can also modulate, and they can actually do this also fairly okay. But there's a bit of electronics added to the actuator in that case, but still it's pretty simple, and there's no complicated mechanics inside. If you look at the gear actuator, there's all kinds of gears. It's called a gear actuator for a reason, I guess. There's a PCB inside, there's a motor inside, there's there's also a logic. And if you look at Danfoss actuators, they actually also calibrate. So so there is a function that that when you connect it to the power, it will find the actual stroke of the actuator. So while the stroke of the actuator might be 5 or 6 millimeters, if the valve below it is only 4 or 3 or 2, it will just find the closing and the opening point. And you can imagine that all this technology that's inside, and then I'm not even going into the digital actuators that are now gaining in popularity, where we have backnet connection, where we have even wireless connections, where we have all kinds of logic inside that can help drive the controls, that can help drive the BMS system. That just costs money to create. I mean, it's also why the old Nokia phone is much cheaper to make than an iPhone, I guess. There's a lot more technology involved. There's touch screens. There's all kinds of things that are inside that actually cost money to produce. So I would, if you ask me for a recommendation, then I would also recommend to go for gear actuators, despite the fact that they are more expensive. And the reason here again comes back to control. The control with a gear actuator is just much more precise than with a wax actuator. And most wax actuators are actually just on-off, which is anyway not something we recommend as Danfoss, because on-off controls are really wreaking havoc on the let's say the energy efficiency of your building. So it will create problems with delta T in the building. It will create problems also with stability in the room temperature. So for sure, I would not recommend on-off, and then definitely not on-off with wax actuators. And if you want to have proper, precise control, then gear actuators is the way to go, basically. So
yeah, clear, very good, Stanley. And that also maybe allows me to show one other document that we have available for all of you out there. We call it HVAC Application Guide, and it's a big document, as you can see, with almost 90 pages of meaningful content. So this is a document that all of you can very easily use to compare different applications. There's a content structure defined for different applications and different principles in here. And then I scroll a little bit down to the table of content, which is again actually interactive, where you can, for example, find the application that was just questioned and answered by Stanley with PICV in combination with either an on-off actuator or with a proportional control or with digital actuator. If you click on the application, you will be guided immediately to that specific application page where we tried to give a summary of the application with the good, the questionable, or the bad even, if that is valid, about the application and which solution to use. And then if you find a certain application that would be relevant for your project, then you could select on the different products and, for example, click on the product that is mentioned in the application. So in this case, I click on the AME actuator, a gear actuator, and then you will be immediately transferred to the relevant page with these actuators. And here you will find some summary of the actuator information. And then when you click it here on the column of datasheet, then you will be again linked to the datasheet document with all the technical specifications. So just as a partly answer to the question as well, such document could be very relevant and interesting for you to have. My colleagues will again show you a hyperlink to it in the chat function on your live stream, that you can download it. And it's available as well in different languages. So yeah, I think it's a good way to show and for all of you to easily find what you're looking for, including a direct link to up-to-date technical informations, which might come in very useful to have. So let's see if there's any other questions coming in at this moment. Not so. Yeah, again, to everybody viewing this, keep the questions coming. And for now, let's turn back to Stanley and see where he is in his presentation document. Till do we have some new question coming in? Stanley.
Yeah, I kind of more or less at the end of the presentation. So I think also we're kind of at the end of time. I see a question coming in still, so let's see if we can catch that one.
Let's see. Can you zoom?
Yeah, all right. So I can read it. I think people can see it on the screen, right? So
Yeah.
So cooling, heating, energy consumption on the premises, and that is definitely something that is nowadays a something that's coming up a lot, because yeah, I think that when I was talking a lot about energy efficiency, and I mean, we see that, for example, the west part of the US is now seeing temperatures of 40, 45 degrees. So we kind of are confronted with the reality of climate change, and so yes, there would be there is a big need to see and to identify energy waste in the building. So there are, so I would say, would Danfoss PICV be able to do this? The short answer is yes. The long answer is pretty complicated, I would say. But we do have versions that actually combine flow meters, for example, with PICVs, which then gives you, together with digital actuators, gives you a perfect, let's say, energy view of the building, because essentially what you need to do is you need to know the flow and you need to know the differential temperature, because the flow and the differential temperature basically give you how much energy goes to a certain application. So let's say a room or an air handling unit. So and there is also different levels of precision that you can have there. What we say is that basically, because of the predictability of our PICV, is more or less, if you know how far it's open, that you can basically see what is the flow. And if you have the delta T measured, then you know also what is the energy use. And this can be very useful as a quick fix to see what is the comparative energy use in buildings. And actually, I mean, as we see, BREEAM, for example, asks for this this energy measuring, and we can actually, and they accept PICV as a solution. So PICV with Novacon, our digital actuator, is a solution that can be used, for example, to score BREEAM points. So now, because we are talking about energy efficiency much more nowadays, also additional precision is sometimes requested. We can say it's needed, yes or no, that's another question. But and this is also probably, I think, where the EPIV comes from, because it can measure the precision pretty precisely. So, and if you want that precision, then yes, we also have solutions that basically combine flow meters with our PICV. But the important difference here is that our solution always includes a mechanical pressure controller, and that is the crucial part about the control, because we can put all kinds of functions on control valves. However, the important part is that it is a control valve. So you want to have proper control in your building, you want to have proper control in your room. And then, energy meters have existed for decades, basically. So if you want to be really precise, you would have to use an energy meter. Are there solutions in between? Yes, there are. Does Danfoss, by the way, we also sell energy meters. And we have every solution in between. Does the PICV in itself can do it? Yes, it can. However, there are certain limitations on how precise this is.
Yes. Great, Stanley. We again have a question from Farhan coming in about the PICV. And that is about if there are any minimum requirements in regards to the characteristics like turbidity, to the water characteristics. Let me be a bit more specific for you. So I guess this refers to the requirements of water quality, as I see that.
Well, I see two interpretations here. One is the quality, and we kind of touched on this before with the steel piping question. So I would say normal requirements there apply. Another way which I could is that it has to do with the turbulence, and this is also a comment that comes up a lot, specifically because we now have EPIVs that need actually straight piping because of the turbulence. For ABGM, this is not needed. So you can mount PICV straight behind a bend or behind an elbow, and it will be precise. So that is also one of the advantages of using this solution versus other solutions. But so for as far as the quality of the water, there are no specific requirements. However, obviously normal maintenance procedures apply, right? I mean, it's not like you can just shove everything into the installation and expect it will work. But by the way, probably the first thing that might clog or might give you problems is your heat exchanger. But if we talk about turbulence, then there are no specific requirements for PICVs.
Okay, that seems like a good way to answer this, Stanley. Thank you very much. And I'm also looking at the questions coming in, where there seems to be a delay or a stop of new questions coming in. And in the meantime, we have been talking already for more than 1 hour about this interesting topic. So maybe it's time to think about the end of this live stream session. And we would very much like the audience to help us find the relevance of such a session as this. So we would like to ask you for very short one question, poll question only, and my colleagues will now put in a hyperlink into the chat where you can click on that. You will be basically questioned just one thing, and that is about, did this session help you to have a better or another understanding about HVAC control valves? Do you have a certain preference? And if so, did this live session change maybe your mindset onto this? So while you receive the hyperlink in your chat at this very moment, no matter if you're on the Facebook or LinkedIn or YouTube, you should all see now the hyperlink. And let's decide to have just a very short time, maybe 30 seconds of time for all of you to just click the link and give us your feedback to this question, if this session helped you. And then the plan is to take the results of this very simple poll question into the live stream, so everybody can actually see it, and so you can also compare what is your answer with other people joining in this live stream. That could be very interesting. So please click the link and make your choice, and then when my colleagues are ready, then let's reveal the results of this poll question, and then we wrap up around on that.
Yeah, so I think what we would like to mention also, we are, as I kind of said during the presentation, this was very much the skating, or not even scratching the surface, I would say, of everything that's behind it. And I think that people that have seen me do presentations, which I've done basically in, I wouldn't say every country, but in many, then they have heard me talk about many of these things. But this is supposed to be the first of a series of live stream events that we will do, and we will go deeper in certain topics that either are relevant or that because of let's say timely situations, or that are that we just think are very interesting. So please watch this space, I would say, for any announcements of further live streams.
Yeah, definitely. And we're looking into the results of the poll screen, but we need to have some technical issue solved before we are able to do that. So trying to look into that at this very moment. Let me try. Will this work?
So you see the technology
yeah,
tricky.
Yeah.
And there it is.
I quickly saw something, but then the screen turned black again. I don't know if that was for sure not the intention. No. That's a pity. That would have been really nice to see how this ended. I get an information from colleagues that maybe you have not seen the link in the chat function yet. So I'm not sure if that means that we don't have any answers coming in so far. If you didn't see it yet and you now see the hyperlink to this site, then please give us your feedback. After all, we'll try to put it in.
I see the link now in the chat, so I guess people can also see.
Yeah, should be there, but Okay. No, I think.
But then I guess it's time to close off.
Yeah. And then we apologize for this functionality to not work. Hopefully, we can include your replies in the recording that is done of this live stream session. So if you have the time to look back for the live stream, it's good to do that. So that really brings us to the end of this live stream, and we thank you very much for your participation and contribution, and giving us all your questions and thoughts regarding the pressure independent temperature control. We hope you found it relevant and interesting, and that we would be seeing you back in another occasion with another topic coming in the near future. So thank you very much all for joining us. And in case you want to know more of us or Danfoss Solutions, remember that you can always apply for our email newsletter or follow us on one of the social media channels on LinkedIn, Facebook, or YouTube to keep up-to-date information regarding our solutions. So thank you very much from our side. Wish you all a very good remains of the day, no matter if that's morning, afternoon, or evening. Enjoy the rest of your day, and hope to see you next time. Thank you very much.
Thanks.